So one question that I want to leave you with, and then I'm going to wrap up so we can start early with our second session. The question I want to leave you with is, how should we choose the statistical threshold C? So it was suggested earlier that we could increase the, or rather decrease the type 1 error by making C larger. But what if we made C smaller and therefore increased the power? So there's that trade-off that I want to show you graphically in a minute. But before I do that, I want to just give you the human element to this. Should we always be using 2.5% type 1 error? Should we be careful to think about the probability of false negatives? And the example that I want to give you is to compare pancreatic cancer drugs with drugs for eliminating toenail fungus. Now, I don't have personal experience about either, but I'm told that both of them are incurable diseases currently, and we have no existing therapies to deal with them. We can deal with some of the symptoms, but we have no effective treatments for either. Do you think we should use the same 2.5% for both? If you were a pancreatic cancer patient, might you be willing to take a little bit more risk than the 2.5% for a false positive than if you had toenail fungus? Well, there is a way of adjusting it, and it's actually in the paper that was also included in your packet. At the time it was an unpublished paper. It's going to be coming out the day after tomorrow in JAMA Oncology. It's a paper that Sho and I and some collaborators have done where we show how you can adjust for the p-values using something called Bayesian decision analysis. I'm not going to get to it today, but I want to just leave with you the basic idea about how we go about it. So here's the old null hypothesis with the same unit standard deviation and the 1.96. And here's the alternative hypothesis that looks like this. And the idea behind changing the threshold of type 1 error is simply, instead of using C of 2.5%, what if we change that? So here's the old case where we have the trade-off between type 1 and type 2 error. Suppose we move the threshold over a little bit. And instead of using 1.96, what if we use 1? If we used 1 as the threshold, then what we get is a very different trade-off between type 1 and type 2 error. Now we've got a much higher probability of false positives, but we have a lower probability of a false negative. And for something like pancreatic cancer, this might be an interesting alternative. Now there are consequences of this, which is that you start approving more and more drugs, they're going to have side effects, and that could come back to haunt you. You have to be wary of that issue. So this is very controversial, and there's a lot more work that needs to be done before it becomes something that would be of practical value.